right microphone on. All right, here we go. Okay, you guys, this was terrible yesterday. Boy, he starts with a negative. Cereal bowl. I had to slap a table. 3, 2, 1, go. Oh, I just gave it away. I had to slap a table. That's why I slapped the table, because no one said table yesterday. All right, next. Which way does this go? Don't answer yet. Oh, and we'll just say negative 16x. Which way does this go? You only have one answer. 3, 2, 1, go. Left. I appreciate at least right. I don't appreciate up or down. You've got to get your files organized. Y squareds are either right or left. X squareds are up or down. I yelled at you yesterday. People said, I'm so confused. I don't get your files organized. Now, why is it left? Because it's negative. Okay, then what's P equal to? 3, 2, 1, go. It's okay. Technically, a math teacher would probably be a stickler and say it's -4 because you set 4p equal to 16 negative, and then you solve. And then you'd be a fool not to graph. So 0, 0 is what all the vertices are. Are you done over there? Focus, focus. Okay. And then I go 4. Which direction for the focus then? 3, 2, 1, go. Left, because it's got to be the cereal. And then I go 4 right for the table. And then what's the equation of the table? Is it x equals or y equals? 3, 2, 1, go. X equals. Let me put this over. No, I'm not doing it anymore because of time. And then I don't get why my cat students screw this up all the time. They're going to be doing this next week. I get to do the whole thing again. Show the James Webb. No, I'm sorry, the Hubble telescope video, and because we're doing parabolas. And this is when my classes get confusing. I'm teaching the same thing in both classes. But how do we miss? What axis is that crossing through that dotted line? Which axis? 3, 2, 1, go. X. And then what is it crossing through? What number? 4. X equals 4. I don't know how we screw this up and say y equals 4. It's a very simple thing to know a vertical line's equation. All right. And then the focus is -4, 0. I had to think about it. And you'll get marked wrong so quick your head will be spinning if you don't write a full coordinate for focus and an equation for a directrix. I will get directrix equals 4. You're gone. I will get directrix equals 4, 0. You're gone. Directrix is x equals 4. You're good. All right. There's only one answer. Okay. So make sure you know that. And then one more thing. How far do I go up? And then how far do I go down in order to make 2 more coordinates? 3, 2, 1, go. 8. Good. Okay. So you go 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Input, say it. That's going to be an input-output point. 1, 2, 3, 4, 5, 6, 7, 8. I'm so happy. Oh, I think it's been 5 years now. Sometimes I lose track of my years. I made a commitment to input, say it, because everything applies to it. Everything when we deal with a graph, input-output applies. Well, first of all, 0, 0, input-output. I input 0 here. I get 0. 0 squared is 0. 0 equals 0. True. That's what a graph is. Every point on the graph makes the equation true. That's what the backbone of input-output is. -4, comma 8. Ooh, that air was rough in my lungs. And then -4, comma -8. -4 for x. Oh, over here. -4 times -16. Oh, 46, 24, 64. 8 and -8 squared is 64. 64 equals 64 in both of those points. So I know these 3 points solve that equation. Those 3 points are on the graph. That graph is a parabola going left. Okay, now I'm done with that. We're going to move on. Okay, do cross this off for a second. This is our equation for tomorrow for circles. All right. So equation for circles. But the reason I have it up there is because of h comma k, which I actually said in my first and third hour, you know what? We've already had the letters h comma k. We've had it in this. x minus h squared plus k. That was vertex form of our chapter 2 parabolas. And then h comma k was the vertex. But now we got to get this out of our head because that equation doesn't help me find p. You got it? I want P because of engineering. I want P because of the video I showed you about Hubble telescope. By the way, did you hear that? That mirror was off by less than 1/50th of a human hair? Did you hear that in the thing? So a human hair, however thick that is, 1/50th of that, that's how far that mirror was off to mess up the Hubble telescope. Imagine the engineering needed in order to even get that close, much less be perfect. That's why those people are the heroes. I cannot be more impressed by people that dedicate their lives to that stuff. All right, and then just know the definition of a parabola. These distances are equal, so I already have that here. And then there's a reiteration. And this is it. This is my cat notes. Meow. Right, and I decided why wouldn't I just use this for the other students, the IM tours and IM. So again, x squared equals 4py up and down, y squared equals 4px right and left. Now, that's when the vertex is at 0, 0. Maybe add that. That's when we have a vertex of 0, 0. All we're going to do today is change the vertex. So therefore, when you look at this, notice, first of all, I put that right here. Notice the h is always with the x. The k is always with the y. All we have now is not x squared. We have x minus h squared. H is the vertex, comma, k is the y coordinate of the vertex, is what I should say. But then notice when we have a y squared, y is with y, x is with x. So this is the y coordinate of the vertex. That's the x coordinate. And then notice, what are the signs? They're all whats? Minuses. So in both these cases, we got to think opposite. Remember back up here, it was opposite same from when I crossed this off. Well, that's because k is on the same side as h. If I would have subtracted k from both sides, we're already turning this into the other format. So that's why it's opposite what we think. All right, and then I'm going to tell you what to do right now. This is going to be fun. You ready? Get your pen, get ready. And you want to get nuts? Let's get nuts. Get rid of all this crap. Get rid of it. You know why? That's your formula, people. That's your good foilers. Say it. Are you just saying it, though? Are you still using a trick you learned last year and then use your trick? There, I factored, and then go on to the next question, and your answer makes no sense to the question. All right? You're a robot trying to memorize this. I'm going to tell you a story. I used to teach this. Hey, you got to memorize this, kids. Then we're going to go to ellipses. You got to memorize all that formula stuff. Then we go to hyperbolas. Memorize all that formula stuff. And it didn't work. It was awful. It was too much for the kids to memorize. So I came up with, this is my patent, serial, say it, bowl, then what? Table. Serial bowl table takes care of all of this, all of it. So that is why I have this over here. Put a big bang on that one. Absolute exclamation point. All right. New word, focal length is what P is called. What do I say? P is the key. All right. They call that the focal length. Don't worry about that. I don't think I'm going to ask you, what's the focal length? Just an extra vocab word. I will ask what the focal width is. That gives me those 2 extra points. Okay, get ready to giggle. Here we go. Another word for focal width is length. I don't know. I'm just the informant. Length of the lattice rectum. Oh boy. I don't know what that word even means, but that is the truth. So if they ask, what's the length of the lattice rectum? It's the focal width, whatever 4P is. I'm being serious, and I think on my a worksheet coming up, you're gonna have that term. What's that? All right, and that is true. Okay, now here we go. We'll do group responses today. So this is why I provided the notes. I'm glad I did because I think we're going to be faster than the other periods. I told my story about space already, so we're good to go. Listen, we're already going to start now. We're starting to devolve into a bunch of, okay. What is the vertex? Careful. 3, 2, 1, go. Oh, I heard louder people say -3, 2. Then I heard some people say 2, -3. Which one's correct? The first one. It's X, comma Y. X is with X. Y is with Y. Do not fall for that. Otherwise, everything else is going to be wrong. If you don't get the correct vertex, you will get everything else wrong. Okay, so maybe you can draw those zero arrows. I didn't do that with the other two periods. I feel like I think about more stuff to write when I'm actually taping. All right, and then everyone should get this right. He's very judgmental. I don't care. There's a job you're supposed to do. You're supposed to get these things down. So I'm going to ask you, what is P? What is the number? 3, 2, 1, go. I got nobody that said what P is. Okay, let me circle where we're at here. It's in this position. That's where the thing is where it's supposed to be. Now, everyone tell me, what does P equal to? 3, 2, 1, go. I just got 34 different numbers in this hour. How many people said 1? Raise your hand. Good Lord. All right, sorry. He's so mean. We've done this for 2 days. That was the 4P position. So all I have to do is put 4P equals 4 and then P equals 1. I don't know. Okay. All right. Let's move on. So then it's going. Oh, did I ask you? Oh, darn it. I shouldn't have given this away. Apparently I told you it's either right or left. Which one is it? Right or left? 3, 2, 1, go. Right is our positive move. P is a positive one technically, but the number in front of the X is or the parentheses of X is a positive. So even if you don't have a coordinate plane, you'd be a fool not to graph this real quick. Okay, so I go to -3, 2. -3, 2. You make this so it's like a grade school question. All right. A grade schooler can't do this. They don't know what these equations even mean. But a grade schooler, after you graph the points, could tell you what the point is. So, which way should the focus go? Right, left, up, or down? 3, 2, 1, go. Right. Now we got more people. And then I could ask a grade schooler. I could certainly ask Lexi Samuelis, hey, what's the coordinate of that X? All right. And she would say, oh, it's left 2, Dad, and up 2. She's my 7th grader. Certainly she knows that. And then she might not know this, though. When I go left one of the vertex and I draw this dotted line, she might not know this equation. But you do. What is the equation of that? 3, 2, 1, go. X equals, and then it's going through the x-axis at -4. I don't understand how anyone could screw that up. I really don't. Very judgmental. I don't care. Math can be easy. All right. Now, how far do I move up from the x to create my 2 other points? How far? How far above and how far below? 3, 2, 1, go. 2. I only have one person answer that. Because 2 plus 2 equals what, everybody? 3, 2, 1, go. 6, someone said. I think they're just messing with me right now. 2 plus 2, get your calculator out, is actually 4. All right. And then this distance is 4 from these 2 points. 2 above and 2 below. You cut the focal width in half. And then watch this. Before I graph it, input, say it. Output. Do you know what this coordinate is? It's -2, 4. And then this coordinate is -2, 0. So apparently these should be input outputs. I got to kind of shrink this down. And watch. Oh, and by the way, the vertex is, look, the vertex, -3 plus 3 is 0. 0 times 4 is 0. Y minus 2, or 2 minus 2 is 0. 0 equals 0. That's why that's the vertex. Input, say it. So if you check that real quick, oh, I know I have the right vertex. If you put 2 comma negative 3 and tried to put 2 in for x, you get 2 plus 3. Nope. This is zeros of each one, and x goes first. Now let's actually check this point. Negative 2. Careful, it's over here. Negative 2 plus 3 is 1. 1 times 4 is 4. Hold. And then 4 for y. Nice. 4 minus 2 is 2. 2 squared is 4. 4 equals 4. That's what input output means. True. And then negative 2 comma 0. Negative 2 plus 3 is 1. Same thing. 4. 0 minus 2 is negative 2 squared, which is 4. 4 equals 4 again. That's for those that do the right thing. Then you have a chance to check. Do those points actually solve if you have time? Okay, we don't always, so just want to make sure. And then the focal width is just that 4 number. 4. Okay, I don't really care about anything else. Next, what is the vertex? Because we have bigger fish to fry coming up here. Fish. Okay, what's the vertex? 3. Uh-oh, we lost that group. What's the vertex? 3, 2. Jimmy, what's the vertex? 3, 2, 1, go. Negative 4, what? Negative 1. And it is x's. Jimmy, you just made the video. Nice. All right, and then what's p? Oh, he's gone again. What's p? What's p? What is it actually? 3, 2, 1, go. Negative 3 would be appreciated. I'm not going to ask you, what's p? I'm just going to look at your graph and make sure that you did get the right things. Because if you said 3, I'd be like, okay, but just make sure you move in the right direction. Oh, by the way, which direction is this going? Up, down, right, or left? 3, 2, 1, go. Down, everyone. If you said right or left, I'd almost ask you to leave the classroom. So I literally just said your file's got to be organized. X squareds are up and down. Y squareds are right or left. So right or left should not have been, not even been an option. Okay, nobody did. I'm just being mean. All right, negative 4, 1, 2, 3, 4, negative 1. That is a vertex. And then which way should I go for the focus? Which direction? 3, 2, 1, go. Down. 1, 2, 3. And then which way should I go? Up. 1, 2, 3. And then, hey, which axis is this dotted line crossing? Which axis? The y. And where is it crossing it at? 2. How could anyone screw up an equation of a horizontal line and an equation of a vertical line? The ones that might be tricky is when they go through 0. X equals 0, y equals 0. That would be the only one. And then focus, I could get Lexi Samulus, left 4, down 4, negative 4, negative 4. Or I know I have to go down 3 from the vertex. That's subtracting 3 from the y coordinate. And then going up 3, adding 3 to the y coordinate, and then that's what y equals. Okay, if you do not write coordinates, you are gone. Or coordinates or equations of lines. Said that already. How far do I go right? How far do I go left? 3, 2, 1, go. 6. 6 plus 6 equals what? 1, 2, 3, 4, 5, 6. I'm not going to bore you with input output. 1, 2, 3, 4, 5, 6. But if you had time and those coordinates that you found there, those would be making the equation true. I'm so glad 5 years ago I committed to input output. It has so many. Anytime we graph, anytime we put anything in a coordinate plane, we can make that association. You are a fool if you don't graph these in order to get these answers. So go ahead and make a picture real quick. A fool. What dictates everything? Serial table. Fool if you don't graph this. Fool. So notice what it says up here as they're doing is find an equation. Now I'm going to ask you, and you should already know the answer because you should have already graphed. I think I said this already, or maybe I'm thinking of last hour. Why I love this is probably like my third favorite thing to teach. My first favorite is any trigonometry, which, we're doing that next semester. Second is logarithms. Oh, I love logarithms. My third favorite thing is conic sections. I love this, but I actually love it because This is really those that are bad with a coordinate plane. You need to know a coordinate plane in order to do any conic section stuff. All right. So knowing where these coordinates are. All right. And then notice what I did before I ask you this question. This is in my head that the vertex is a point on the graph. The focus is not. So I always make it an X. Now I know my symbols. I know what I got here. Okay. Which way is this going? Up, down, right, or left? 3, 2, 1, go. Matina, you okay? You're holding your head together like your head's about to explode. No, you just made the video. All right. So everyone, did you say right? I was afraid you weren't going to say it. Okay. So by the way, if it's right, is it x squared or y squared? 3, 2, 1, go. Y squared. And here's what I'm trying to fill in. Y squared equals 4p x minus, I didn't say y minus k squared because I have not a 0, 0 vertex. Okay, well, the vertex is -4, -4. I don't have to bore you with this. So that's going to be y minus -4 for the y coordinate of the vertex. And then this is going to be x minus -4 conveniently for the x coordinate. Now, what is p? It's staring you in the face right now. I could just look right here. You see me? What is p? 3, 2, 1, go. 2. This is the whole idea of what P is, being the key. It is the distance the vertex is from either the focus or the directrix. I already have it. P is 2. Final answer is y plus 4 squared equals 8x plus 4. Okay? All right. Now, that's where the fire drill happened. Actually, the fire drill first hour happened before that. So I didn't even get to this next one. I didn't even finish this first one. And we didn't even get to completing the square. I should have told my first hour to watch the end of the video. In fact, I'm going to put a passive-aggressive note on the calendar. First hour should listen to the last few minutes of this video to watch completing the square because it isn't going to take that long. And actually, this other one. So go ahead and do this one. Jump ahead of me here. I should freeze the screen. It's too far away, so I won't. So I'll go super fast. Before I draw anything, in 10 seconds, I'm going to ask which direction do you think this is going? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Which direction is, I guess it's going to be 13 seconds. Which direction, plus I'm talking a little bit longer, so it's longer. Which direction is this going? Up, down, right, and left. 3, 2, 1, go. Up. Okay, so I gave you a little extra time screwing around there. 3, 4. That is the focus. Y equals 1, knowing that is a horizontal line. Oh, well, yeah. The parabola must be a bowl in between those two facing up to be, the correct serial bowl table situation. Okay, now, this is where it gets tough. This distance, it's not though. It's just because people hate fractions. Hint, hint. That is a distance of 3. What is P then? The answer is not 3. What is P? 3, 2, 1, go. 1.5. You guys are way better than third hour. Third hour, I get a bunch of different answers on that one. Just half of that. Ah! I just got disconnected from the screen. I hate that. This happens all the time. There, I'm evidence right there. I punch the screen all the time because technology drives me nuts. Okay, now, by the way, is this an x squared or a y squared? X squared or y squared? 3, 2, 1, go. X squared. It's going up, so it's an x squared. I feel like it's getting hot in here. Whew. The heat is finally working, and it's 75 degrees outside. Thanks, Lockport. All right, then y minus k. Oh, wait a minute. We got to find the vertex. Okay, so it's going to be 3, comma. How far do I have to go up from this dotted line to get to the vertex or below this x? How far? 3, 2, 1, go. 1.5. Here's 1. What's 1 plus 1.5? 2.5. So the vertex is, careful, it was 3 for x, then 2.5 for y. So it's x minus 3 squared. You guys are in honors. What's 4 times 1.5? 6. Okay, I was waiting for the first person to say it. And then y minus 2.5 because I want to get to completing the square. Okay, and then you don't have to find anything else, but you got to make a graph to establish seriable table to establish what you're dealing with. If you don't graph, you're a fool, and that's the bottom line of it. All right, now it's time for completing the square. All right, you ready? What time do we get out of here? Are you okay? 49. All right, we got 11 minutes. It's like an eternity. In this class, I might feel like that. Anyway, by the way, you have a 50-50 chance on this. This is going to be a parabola. Which way are the possibilities? Is it up, down, or is it right, left? 3, 2, 1, go. Oh, no. I heard a half and half. What is the squared variable and the only one that you see in there? Which one? 3, 2, 1, go. Who's y squared? Is that up, down, or right, left? 3, 2, 1, go. Right, left. Okay, so you should know right away that this is a right-lefter because there's only a y squared, and this is the first time you're going to see completing the square. And some of you won't believe how easy it actually is. And we're going to get a new Samulus saying here, something that you will remember, and we'll probably use it quite a bit the rest of the year. This is completing the square. Okay, but what we got to understand is, okay, we got to turn this into this. We got to turn this into the standard form that you just saw today. But you saw something similar without the H and the K the last 2 days. So it shouldn't be that big of a stretch. So again, we got to be a problem solver. Okay, I got to complete the square in this parabola because I'm going to tell you right now, when we do circles, ellipses, and hyperbolas, the completing the square is going to be a little bit different for each one. It's because of what the standard form looks like. So the first thing is, what's my objective? And that's my objective, to get it to look like that. So what that tells me is I want the y's on one side and everything else on the other. So here's step 1, get the y's together, but hold on. Put a blank there. I just have a question. Whatever you do to one side, say it. We're going to do something to both sides to make this happen, to make this set of parentheses happen. And then this is honestly the biggest mistake. This makes me cry. The biggest mistake is, how do I move 6x minus over? I add it and subtract it to both sides. So I add 6x to both sides and I subtract 13 from both sides. That gets rid of it over here and then puts it over here. This is the number one mistake in completing a square and a parabola. It makes me want to hit my head up against the wall. It's grade school. All right? The grade school stuff. Don't ever say IM2 is too hard. It's the other stuff that you're doing that's making this class too difficult. Oh, by the way, whatever I do to one side, say it. Do to the other. Why is he putting that blank here? Now, I had someone come into Compass from first hour. It was awesome. She just needed to look at her test. By the way, don't complain like I had parents complaining Monday. Well, they never get to look at their tests. I go, stop right there. Your son, daughter, whatever, has chosen not to come into Compass to look at that test because that's what Compass is for. All right? It drives me crazy, these lies, this fake news, all right, that you guys are spewing out there. So if you ever want to come in and see a test, come in Compass and we can spend all day long looking at that thing. Anyway, that girl kindly came in and we started completing the square. And I asked her, okay, understand the objective. Whatever I do to one side, say it. Do to the other. I want to put a number here so that this is factorable, and it's factorable where it's y plus or minus. By the way, it's going to be plus the same number, so it becomes y or plus or minus the same number. So it's a binomial squared, because that's what this looks like. So I asked her, what do you think that number should be? So that MA follows where it's the same number times itself. Hey, everybody, what do you think that number is? Be like her. 3, 2, 1, go. 1. It's okay, though. Why is it 1? What multiplies to 1 and adds to be 2? What two numbers? 3, 2, 1, go. Oh my gosh, did you guys forget how to factor? What two numbers multiply by 1 and then add to be 2? 3, 2, 1, go. 1 and 1. So this becomes y plus 1 times y plus 1. You will never write this again, which is y plus 1 squared. Whatever you do to one side, say it. This is the second biggest mistake. Actually, I might circumvent that. The biggest mistake is not adding 1 to the right side to keep the balance. Whatever you do to one side, you do to the other. You chose to add that 1. Okay, now that's what we did. Now I'm going to tell you how to complete the square, and then we'll practice it. You know how you complete the square? It's a new Samulus thing, which I think most teachers say the same thing, so I can't patent this one. When I say complete the square, you say take half the middle term. What's half of 2? 1. And then square it. What's 1 squared? That will always make a perfect square trinomial that factors into a binomial times itself. And we'll practice that, but hopefully the first one is good. This becomes 6x minus 12. And then to get it in the format that we want, we pull that 6 out. And you're left with x minus 2. So see how that one little thing that I did turned this into a binomial squared, which matches the formula I need for a parabola. Okay, now what is the vertex? Careful. Now I see this. What's the vertex? 3, 2, 1, go. 2, -1. You should know this because we just had this. What's p equal to? 3, 2, 1, go. 1.5. We just had that where 6 is our p value. Let's practice complete the square real quick. Hey, just pretend I wanted you to just complete the square on this. Y squared, what am I doing? I'm sorry. Let's do minus, and then let's make it easy, 12y, and then plus blank. Just tell me, what do you think belongs in that based off of the thing that I told you, and then we'll prove it. 3, 2, 1, go. 36. What's half of -12? What's half of -12? Not 6. -6. But then what's -6? Get your head up. Squared. What's -6 squared? 36. And then factor this. What multiplies to be 36 and adds to be -12? I'm just going through what completing the square means. What does that become? Y. Go ahead. 3, 2, 1. Y minus 6. Y minus 6, because you need -6 plus -6y, which is -12y, which in turn is y minus 6 squared. So I was just showing you again, when I say complete the square, let's all say, when I say complete the square, you say take half the middle term. We got to start over. He's in his own world over here. Let's start over. So Nico got in the video. All right. So let's start over for Nico. So when I say complete the square, you say take half the middle term, then square it. We got them. Okay, that's what we got to do. All right. So let's now go ahead and do this one. Oh, this one's weird. It's another y squared. Okay, so y squared plus 16y plus blank. Watch how easy completing the square is actually. And then because it's a parabola, add x. So I got people putting their stuff away. That's a good signal for a teacher. I don't care about what you're doing, Mr. Samulus. Who cares? Ooh, you got that bag. Ooh, there's a minute and a half. Oh my gosh. I got to check my phone. Ooh, how many messages did I get while I was Okay, and then whatever I do to one side, what I do to the other. Okay, what number goes in that blank if you take half the middle term and then square it? 3, 2, 1, go. 64. And then you'll see why half of 16 is 8. You'll see why I'm writing this work as a little thing here, because when it gets a little bit tougher to complete the square, you're going to want to write that little work down, but you don't need to right now. And then you should get it. By the way, whatever you do to one side, do to the other. And then what is this factor to become? What multiplies to 64, and those same two numbers add to 16, everyone say it. 8 and 8. So this factor is to become y fumble plus 8 squared equals x plus 63. This is an interesting question. First of all, the vertex is negative 63. Go ahead and start putting your stuff. Negative 63, negative 8. Check those phones. All right. And then if you're a charlatan, put those earbuds in. And then what is P before you leave? What do you think P is? 3, 2, 1, go. It's a fraction. 1/4. Because this is 1 here, so 4P equals 1. All right? Nice. Good timing. I'll shut this video down.